The useful life of a certain car battery is normally distributed with a mean of 100,000 miles and a standard deviation of 10,000 miles. The company makes 20,000 batteries a month. Let's answer the following questions. So we're just going to use our normal distribution and the empirical formula to answer the following questions. So about how many batteries will last between 90,000 and 100,000. So we know that the mean here, let's see, is 100,000. Here is our middle number. There's our mean. And our standard deviation is 10,000 miles. So for every standard deviation would be 10,000. Two standard deviations would be 20,000 away, and so forth. And we want to apply that to this 20,000 a month. How many batteries? So if we look, so we want to know between 90,000 and 110,000. So if we move over and look at our empirical formula here, our normal distribution, and applying the empirical formula, we see that this middle number, our mu here, our mean is 100,000, and it was interested in from 90,000 to 110,000, which we see is just one standard deviation to the left and one standard deviation to the right. So we see that 68% of those will lie in between those numbers. So all we need to do then is just apply that 68% to this question. So we would say, well, of the 20,000, of the 20,000, 68% or 0.68 is going to be between 90,000 and 110,000 miles is how long that they will last. So when we multiply 68 or 0.68 times 20,000, we get 13,600. So then about how many batteries will last more than 120,000? So going back to our setup here, 120,000 we see is above two standard deviations. So we're interested in everything above two standard deviations. So that would be the 2.35% and the 0.15%, for a total of 2.5% of the batteries will last above two standard deviations. So we would just come back and we would say, well, 2.5% of the 20,000, which mathematically is just saying 20,000, can't make a comma there, 20,000 times 2.5% would be 0.025, and when we multiply that out, we get just 500. So just 500 of them. And then on C it says how many batteries will last less than 90,000 miles. So come back and look at 90,000. So now we're interested in everything below 90,000. That's here. So below this is going to be all of this percentage. So 13.5 plus 2.35 plus 0.15 is going to be 2.5 plus the 13.5, or 16%. So 16% applied to the 20,000, we would say is 0.16 times my 20,000 is going to be equal to 3,200. And then finally, what is the probability that if you buy a car battery at random, it will last between 80,000 and 110,000 miles? So 80,000 to 110,000. That's from here to here. So that is two standard deviations to the left and only one standard deviation to the right. So we're just going to add up these numbers here. We'll take 13.5, 34, and 34. Well, we know 34 and 34 is the 68, and then we add to that the 13.5, and we get 81.5%. 81.5% would be our probability.